Welcome to Educator.com. In a previous lesson, we talked about solving quadratic equations by graphing, and we're going to go on to discuss another technique, an algebraic technique, which is solving quadratic equations by factoring. So, first starting out with just a brief review of the different factoring techniques. And each of these are covered in depth in the Algebra 1 series. So if you're unsure on any of these, make sure you review that before you go on, because we're just using these techniques as a tool now to actually solve quadratic equations. Okay, first remember the greatest common factor. And the greatest common factor of two or more numbers is the product of their common prime factors. So the GCF of two numbers is, or two or more numbers, is the product of their common prime factors. And in factoring, often when you're factoring an equation, if there is a GCF, you want to factor that out first, because then you're working with something less complicated. For example, if you had 4x squared plus 16x plus 36, you'll recognize that there is a GCF of 4. So I'm going to factor that out and get 4 times x squared plus 4x plus 9. So factoring out the 4 gives me x squared plus 4x plus 9, and this is much easier to work with. So remember to factor out the GCF first, if there is one. Recall the difference of two squares. You'll recognize this because it's going to be in the form a squared minus b squared. So an example would be x squared minus 4. And that is equal to x plus 2, x minus 2. So this is the difference of two squares. Here's plus and the minus. And so when you're factoring, if you recognize this, you can quickly factor it as the difference of two squares, knowing that it fits into this formula, a squared minus b squared. Perfect square trinomials. Perfect square trinomials would be the result of squaring a binomial. For example, if you have x squared plus 6x plus 9, this is actually equal to x plus 3 squared. So if you take a binomial and square it, you'll get a perfect square trinomial. So take a binomial, multiply it times itself, that's what a perfect square trinomial is. And so recognizing that makes for easy factoring. General trinomials are a little more complex to factor. Again, you can review all of this in Algebra 1, techniques for factoring. And an example of a general trinomial would be x squared plus x minus 12. It doesn't fit into any of these special cases like the difference of two squares or perfect square trinomials. So I have to do a little more work in factoring that out. Recall from earlier lessons that you need to look at the signs. I have a positive sign here, I have a negative here. And if I have a negative, that must be the result of multiplying a positive and a negative. I then look at what the factors of 12 are. And the factors of 12 are 1 and 12, 2 and 6, and 3 and 4. And I need to and one will be positive and one will be negative. And I need to have factors that sum to this middle term, which is actually 1. And I can try different combinations. And I know that negative 1 and 12 is not going to work. Negative 12 and 1 certainly won't work. And I go on down. And from that, you can see that if I want them to sum to 1, I'm going to need factors that are close to each other. And the closest two I have here are 3 and 4. So if I make 4 positive and 3 negative, then when I add the outer term and the inner terms, I'll get my middle term x. And you can always check this using the FOIL method. First terms, that's x squared. Outer terms, negative 3x. Inner terms, 4x. And then the last is negative 12. Simplifying this, I get my original back. So general trinomials take a little more work, and you can always check those by multiplying it back out to make sure you did it correctly. So making sure you have all these, know how to use them well, and then we're going to be using them today to actually solve some quadratic equations. Now, once you've factored, you need to use the zero product rule to actually find the solutions. And what the zero product rule says that for any number a and b, if ab is 0, then either a is 0 or b is 0. Because if a equals 0, then you'd get 0 times b. That would work as a solution. If b is 0, then 0 times a would give you 0, and that is also a solution. For example, if I was given x squared minus 16 equals 0 and asked to solve that, I would first recognize that it's in the form a squared minus b squared, and that it is therefore the difference of two squares. That allows me to factor it pretty quickly into x plus 4, x minus 4. So I'm factoring this, and it still equals 0. Now, use the zero product rule. The zero product rule tells me that if this is 0 or this is 0, then this entire thing will equal 0, which is what I want. So if x plus 4 equals 0, this will be solved. If x minus 4 equals 0, this will be solved. So I'm going to set this factor equal to 0 and solve for x. I'm going to set this factor equal to 0 and solve for x. And that's going to give me, let's see, x equals 4. And if you wanted to check that, you could go back up here and say, okay, let x equal negative 4. So that's negative 4 squared minus 16 equals 0. That is 16 minus 16 equals 0, and that checks out. That is a valid solution. I could do the same thing for 4. So x equals negative 4, I could say x equals 4. And that's going to give me 4 squared minus 16 equals 0. 16 minus 16 does equal 0. So there are two solutions here, and I was able to find those using factoring and the zero product rule. So trying this out, first I'm just asked to factor. And recall that the first thing you want to do is factor out any greatest common factor, because that's going to make whatever's left much easier to work with. And I see that I have a common factor of 4, a greatest common factor of 4. So this factors into 4 times x squared minus x minus 6. Now, all I have here is a general trinomial. So I want to think about what I have, and I want to make sure that I bring my 4 along with me, because that's part of the solution. Okay, I have a negative sign here. And the only way you're going to end up with that is if one of these is positive and one is negative. Now I'm going to think about what my factors of 6 are. I have 1 and 6 and 2 and 3. I need factors that sum to a middle term of negative 1. And that's not a very large number, so I'm going to look for factors that are close together. I'm going to try these first. Now, one is negative and the other's positive. Since this is negative, I'm going to look for making the larger number negative. So let me try, if I have negative 3 plus 2, that equals negative 1, and that is the middle, that gives me the middle coefficient. The coefficient of that middle term. So, this is what I've got. And I can always check that by using FOIL to go back and multiply these out, and then I would have to multiply the 4 back into it. But this is factored, so I first factored out the GCF, and then I saw I can take it farther because this is not factored out all the way. It's a general trinomial that factors into x plus 2, x minus 3 times that greatest common factor of 4.